So, new chapter. It's pronounced polynomials. It comes in two parts. And I mentioned the reason why I split it up in two parts earlier. So the first part is we're going to look at how to basically add and subtract polynomials. And we'll probably be done this around the end of next week, or maybe early the week after that. Right? And the second part is multiplying and dividing these things. Okay? So make sure your name's on here. All right? And our block, we're block 1 of day 2. All right? All right. So today, the goal is vocabulary. All right? So this whole chapter, unit, it's going to start looking at expressions that look like this. Okay? So no longer just numbers. We have numbers and letters. Right? And as soon as we have letters involved in an expression, we call this algebra. Right? Nothing, I don't know, some students get a little anxious when they see letters. Like letters, right, are just numbers that we don't know the value of. So we call them unknown numbers. And they have a name. So this is part of your terminology. Letters are called variables. So I might give you a question. Say, hey, look at this expression here. What variables do you see? And you just got to be able to tell me, like, oh, I see an A and a B and an S. Those are my variables. So that's some of the terminology you got to know. Like you did that quiz the other day with MSS, and there's some questions that weren't very hard on it, but I'm betting some of you guys got them wrong because you just didn't understand the vocabulary. Like, what's a GCF, greatest common factor? If you didn't know it, it's not a hard question. You just couldn't do it. It's a very simple concept, right? So maybe on the big side, letters are variables. So if I ask you for variables, you're just looking for, tell me the different letters that are there. That's all, okay? Now, this is a special branch of mathematics. So the type of expressions that we're looking at are called polynomials, right? And so polynomials are made up of something called terms. Another vocab thing got thrown at you. So what is a term, right? So if this is an expression, like, ooh, it jumped. Where did it go? Zoomed in too much. So looking here, if this is an expression, terms are connected by, or separated by, if you want to use that phrase, addition and subtraction symbols. Okay. So if I gave you this thing here, which I'm calling an expression, say how many terms are there? Well, we look for adding and subtracting signs. I'm going to just draw, here's a subtracting sign, so I'm going to draw a big line through there. And here's another subtracting line, I'm going to draw a big line through there. Right? Everything in between are the terms. Like, so this is a term, this is a term, and this has a term. Right? So terms are separated by plus signs and minus signs. So how many terms are there? Well, there's one here, and one here. Altogether, there are 3 things that we call terms. Is that okay? Not too hard? Okay. So let's go over here. And we're not going to do the names. I haven't talked about the names yet. But get you guys to practice this. How many terms do you see here on this one? Right? Just one. There's no adding, subtracting, separating there. There's one there. Okay? How many terms do you see here? The second one. Sorry? 3, yeah. So if you separated it, here's one here, and there's 1, 2, 3 there. How many terms are here?
2.
2. Okay? And so there's 1 here, separated at the minus sign. Okay? How many terms are here?
2.
2, yeah. Separate here, 1 there, 1 there. Okay? How many terms are here?
1.
Yeah, just one letter, no, nothing else separating, just a, oh, maybe I'll use blue here. And finally, how many are here?
3.
Yeah. You separate at the plus minus sign, so you have 1, 2, 3. That's it. All right? So it's going to be really important to be able to identify terms for 2 reasons. Terms, we match up terms, we add and subtract some things that we call like terms. We'll talk about that next day. And also, the name of each one of these expressions depends on how many terms there are. So you got to know what the names of these things are. All right? So to name something, an expression, a polynomial, right? You count how many terms there are. For example, this one has 1 term, and anything with 1 term, right, is called a monomial. Okay? You'll notice all the names are going to end with this meal part. And the only thing that's going to change is the suffix or the prefix here, right? So mono means 1. So 1, and meal means terms. So 1 term. That's what it translates into, okay? This one has 2 terms, right? You have this one here and this one here, right? 2 terms are called binomials. So nomial. Circle. I didn't go far enough. All right? Binomial. And if you have 3 terms, 1, 2, 3, like this one here, it's called a trinomial. So you have to memorize these names, right? The way I sort of think of this is wheels on a bicycle, 2 wheels, bicycle, so binomial. Tricycle has 3 wheels, trinomial. I know 1 wheel bike's called a unicycle, but it's a monomial. Okay? And Pavitra, you have a question?
I was just gonna say, like, isn't like more than 3 terms called multinomial?
Yeah. So the more than 3 terms, that's the last one there. Because look at this one. This one's got 1, 2, 3, 4, 5, and you're good approach. Multinomial, but instead of using the word multi, we use poly, because the word poly means many, like polynomials. Polyatomic atoms in chemistry, right? You have more than 1, right? So we use the phrase polynomial, right? Now, there are names for something with 4 and 5 terms and stuff like that. We just don't bother with it, right? We're going to know the first 3, and after that, we just call them generally polynomials. Because technically, all these are polynomials, right? These are just given specific names, right? All right. So, vocabulary, right? We got letters are called variables. Polynomials are made of things called terms. Excuse me. And by counting the terms, we can figure out the name. Right? 1 term monomial, 2 terms binomial, 3 terms trinomial, and many terms polynomial. Okay. Now, adding on more vocabulary. So we have things called terms, and every term has something that's called a degree, right? So the names are important, so we can sort of communicate how the equations are. The degrees are important. Not that we're going to get to it in grade 9, but you get into future grades. The degree tells you how the graph is going to look like. So I can look at some of these equations in my mind. I know generally how they're going to look like. Right? So all these equations are going to either look like this, or like this, right? And they keep on going like that. And I can tell just by looking at the equation what they look like. And you'll get there as well. Not in grade 9, right? But you can tell how it looks like by the exponents, right? And the exponents tell you what this degree is. Okay, so how do you find the degree? By adding the exponents of the variable. Right? So you have a term has a degree, we add the exponents. Right? So for example, we have this term here. We look at the variable, which is the letter. So you see how the vocabulary is difficult in this one? So we look at the letter and we go, hey, what's the exponent for this letter? If you don't see an exponent, what imaginary number is there? This is going all the way back to September.
Oh,
1. 1. This has a little imaginary 1. So there's nothing to add up. There's only one variable. So this term has a degree 1. Okay? All right. Now, this one has 2 variables. A variable here and a variable here. Now that you have more than one variable, you have to add the exponents. So the x has a 2 sitting there. The y has a little imaginary 1. What's the degree of this term? 3. That's it. 2 plus 1, 3. Right? Last one, 12.
1.
Does it have a variable?
No.
No, it doesn't have a variable, so it can't have a degree. So its degree is 0 because it doesn't have a variable. Okay? All right. So let's backtrack because I'm going to kind of go back and forward here, trying to keep all these things fresh in your mind. Okay, let's go back to here. Let's finish off this table here. Names. So we already figured out how many terms there are. If something has one name, one term, Gavin, what is it called? Mono. Then the meal part. Meal. Something has 3 terms. What is it called? Come on, boy. Try. Tricycle. Try. No meal. Okay. 2 terms. What is it called? Binomial. And now everything is just a repeat, so you can fill out the rest of the table. Binomial here. Monomial here. Trinomial here. Okay. All right. Like, not hard stuff, just a lot of little stuff, right? Okay. Now, going back to this side of the page. So, every term has a degree. Right? Every term has a degree. You just add the exponents of the variables. But when you start looking at polynomials, right? So everything we looked at here were monomials, just one term. What happens if an expression has multiple terms, right? So we have a term here, and we have a term here, and a term here. So this is for the binomials, the trinomials, the polynomials. What's the degree of this thing? What we do is we find the degree of each part and pick the highest. Right? So we're going to separate this out into terms. How many terms do we see here? 3. Right? We're going to separate here and here. Okay? Then find the terms. How many terms does this one have? Sorry, not terms, degrees. The first one here. 2. Just the x with the number 2. This one has a 2. Okay? What's the degree of this term? 1. All right? What's the degree of this one? 0. Good. Excellent. So now, for this expression, we pick the highest one. So the highest one is the 2. So this polynomial has a degree of 2. Okay? So find the degrees of the terms, pick the highest one. All right. Why is all this stuff floating up in the air? Okay, let's go over here. Okay, find the degree of the expression. Right? So the first one, how many terms? 1. We did all of these above. What's the degree of this one? 2. The x has the number 2 floating up there, so it's a 2. Okay. How many terms do we see here? We did this above. We said there was 3 terms. We said there was a term here, and a term here. So we need to know the degrees of each term and pick the highest one. First term has what degree? 1. The letter A has a 1. What's the degree of the second term? 2. What's the degree of the third term? 1. What's the degree of this polynomial? 2. The highest one. Right? Okay. We said this one has 2 terms. So we had a term here, and we had a term here. So we need to find the degrees of each one. What's the degree of the first term? 1. I'll put a little 1 there. What's the degree of the second term? 0. What's the degree of this expression? 1. Picking the highest one. All right. We said this one has 2 terms. There they are highlighted. Degree of the blue term? 2. Maybe I'll put that underneath this time. Degree of the second term? 1. 2. So we, when you have more than one letter, we add its exponent. So the x has a little 1, the y has a little 1. So 1 and 1 make a 2. Okay? So what's the degree of this whole expression? Sorry, Pavitra?
2.
Yep. The highest one, 2. All right. Erase this. This gets in the way. The R. 1 term. What's its degree? Yeah. There's one little imaginary 1 there. There we go. Last one here. We said there were 3 terms. It's term here, term there. What's the degree of this one? 2. Degree of the middle one? 1. Degree of the last one? 0. So 2, 1, 0. Biggest one is a 2. That's it. Okay? Now, there is one more word that I haven't talked about in terms of definitions. It's called a coefficient, which we talked about earlier. Right? Remember the word coefficient coming up in the past? Right? You may have forgotten it already. Right? So if we have, I didn't write it in here, but I'm going to do it now. If we have an expression, just go in this place. 2x, say, minus 4x minus 5 or plus 5, it doesn't really matter. What's a coefficient? Do you guys remember that one from way back in September? Like, what was when we looked at exponents, we mentioned the word coefficient. Right? No? Nobody remembers? So coefficient was the number in front of your term, your expression. So here, here's your term. The 2 is a coefficient. The number in front, right? So that's in coefficient, and so is 4, the number in front of your variable there. That's a coefficient as well. Okay. The 5, a number without a letter, is called, do you guys remember that one? That came up once. All right. That was a difficult one. So this one is called a constant. Right? Number with no variable. Okay? That's what a constant is. So, lots of terms here, right? What's a variable? Right? What's a term? What's a degree? Right? None of these are hard. It's hard to remember all of them at once. Okay. Now, the very last thing, which we're going to do the assignment today as well, is diagrams. Now, I personally don't use these diagrams very often. I just, for me, they're just slower, having students draw boxes. But for people who are visual learners, it can be handy to be able to draw this expression out and do some manipulation with that. They just find it easier that way, right? But I don't do it too much because it just takes longer, right? Drawing. Now, this expression here, this polynomial, which is a trinomial, is represented by this picture here. There are 3 terms here. There was a term here, there's a term here, and there's a term here. Without me giving you any kind of guidance, could you figure out what does each of these shapes represent? So we have 3 different shapes here as well, right? We have a shape, well, let's do this in black. We have these big squares here. And we have a rectangle here, and we have a little square here. All right? Look at the expression. Look at this thing, which means the same thing. What does each one represent? Can you take a guess? Gavin?
Tiny squares are ones.
The tiny squares are ones. Right? 1, 1, 1. And we have 3 of those. That makes sense. Okay, what else? So we have 2 more to go. These represent ones. Okay? Pavitra?
The 2 black squares would be positive x squared.
Yeah, so now these, maybe I'll do this, change this to green here, are x squares. All right. So our expression has 2 of them. So we draw 2 x squares, big giant boxes. Then we have the white rectangles, Pavitra.
Which would be negative x.
Yeah. And so Pavitra saw something. All right. And so we have 4 x's. Right, that go there. Now Pavitra said positive and negative. She said, hey, these are positive x squares, these are negative x squares. But she noticed one extra thing. There's different colors here. Some are black, some are white. Yes?
It's because the ones that are positive, the one that's negative, which is negative for x, has a minus before it.
Yeah. So like here, like the two different colors represent positive and negative. If the number is positive, it's colored black. If the number is negative, it's colored white. Right? So black is positive. Now white is negative. That's what I use because, hey, when we're printing things out, things turn out black and white. If you use a textbook, they may use reds and greens or yellows and blues. It really depends on the publisher of the company. So there's different colors that these things can come in, right? But I like using black and white because that's how we print everything. Okay, so on the back side is the legend for these. You know, okay, that's a positive tile, that's a positive x tile, that's positive x squared. I have 4 diagrams here. Can you take like a minute and try to tell me what the polynomial expression looks like for each one of these? Right? Just give people a couple of seconds here. Pravito, you want to do the first one and we'll let people go? Okay, what is the first one? A.
I got negative x plus 3.
Yeah, so this one, rectangle is x, it's white, so it's negative. And we have 1, 1, 1, we have 3 of these. So this is negative x, and that's positive 3, so plus 3. So every term needs a sign between them, either a plus sign or a minus sign. So even though it's just 3, we need to put a plus sign to separate these things out, like this. All right? So take each shape, turn it into its expression, and tell me. Give you guys a couple of seconds here. Go a little bit slower through these. Now, here, first step, just identify the shape. This is an x squared. This is an x. These are negative 1s. So just go from left to right. So we have our first shape is x squared. The coefficient that we put in front tells us how many we have. So we go, oh, we have 1 of this shape, so I can put a 1 here, right? Then the next one, we have an x, and we have 1 of these here, and it's positive, so we need to put a plus sign here. We need to separate the terms, right? Now the last one, we have 2 of these shapes, and they're minus 1, so that's minus 2, okay? Now the answer that I put up wouldn't look like this. There's nothing wrong with this answer, except for 1 coefficient we don't show. We just assume it's there. So this, not that there's anything wrong with it, would look like this, right? This is much more clear, but has redundant information. We don't need to show that 1 there. So this is, if there's, what's the coefficient in front of this? Oh, there's a little imaginary 1. Okay? So now these ones, we have x squares here, negative x's here, and 1's here. So we go from the beginning. We go, okay, first shape is x squares. We have 2 of them, and they're negative. That's it. Second shape, we have x's. We have 3 of them, and they're negative. Right? Last shape are 1s. We have 4 of them, so we just add them all together. That's it. Okay. These are x squares. These are 1s. First shape are x squares. How many do we have? We have 2. Next shape are 1s. How many do we have? We have 5, and they're negative. So 2x squared minus 5. That's it. All right.